Right now we're talking about how to set up pedigree charts, and the first one we're looking at is for um, bone marrow function, or for Fanconi anemia. So your bone marrow is responsible for producing new blood cells, and if your bone marrow cannot produce new blood cells, it results sometimes in leukemia or a number of different disorders. So here we can see that the dominant form is normal bone marrow function. So let's put, if we're talking about Fanconi, let's put big F, and this is going to be normal. This will be the normal. And little f is the anemia. This just helps us keep it straight in our heads. So here we see Arlene does have the disease. So this means that she has the recessive trait, little f, and if little f is expressed, then there has to be another little f, because if there was a big F, it wouldn't be able to be expressed. However, George here does not express the disease, so all we know right now is that he has one big F, but we don't know what his second one is. So let's put a little underline there. If we look at his kids, Tom and Wilma, they both have the disease. So therefore, they're little f and little f. Little f, little f. So therefore, we know since Arlene could only give a little f, then George also had to give a little f. So we know that George is big F, little f. So what is Arlene's genotype? Well, she's little f, that's a little f, and a little f. And George is heterozygous, big F, little f. What are Anne and Michael's genotypes? Anne and Michael both do not display the disease, so therefore they have a big F, and that's dominant. So we don't necessarily yet know what their second allele is, but if you look at their child, she has little f, little f. So she had to get those little f's from her parents. So we know that they are both heterozygous. Big F, little f. Most likely, Sandra's genotype. We can't be too sure here, actually. If we look at Tom, we know he has little f, and Daniel, his son, has a big F, little f. Alan has big F, and we don't really know what he has here. We know that Daniel got a little f here. Oh, Alan must have gotten a little f because Tom only has a little f to give. So we can assume that Sandra has a big F, but she probably, most likely, has another F, but let's not put that down unless we know for sure. Let's just put big F underline. Unless we know for sure, let's not add anything. And the last question is, which of these people are carriers? So Anne and Michael are carriers because they have big F, little f. Alan is a carrier. George is a carrier, big F, a little f. Carrier means that they have the disease in their genotype, but it's not in their phenotype. It is not expressed. So let's go to the next page. Here we're looking at neurofibromatosis. And with this disease, there are skin discolorations, and then also tumors grow under the skin and throughout the body. It says here that the dominant form of neurofibromatosis is the disease. So let's put big N, and then we're going to put disease. We're going to write disease instead of neurofibromatosis just because it's easier to write. And so therefore the normal state, not having the disease, is recessive. So let's write normal. And if we look at question number 1, is individual number 1 most likely homozygous or heterozygous? Explain how you can tell. If we look at the first parent over here, this person does not display the disease, so therefore they are little n, because they're normal. And if they had a big N, then the disease would be expressed because it's dominant. So over here, all we know at this point is that there's a big N because they have the disease and it's expressed. It's dominant. But if we look down here, their offspring has a little n. So they got a little n from their dad, and then they had to have gotten a little n from their mom. And so therefore, the offspring is going to be definitely, not the offspring, the number one is going to be heterozygous. I totally spelled that wrong. Heterozygous, G-O-U-S. You get that. What is the genotype of individual number 3? Individual number 3 right here, we know because they do not display the disease, they do not have a dominant N. So they are little n, little n. And can you be sure of the genotypes of the affected siblings of number 3, individual 3? Well, we know that there's a big N, little n here, and we only know of this big N. We don't know what this is because we just know that the gene is expressed. We don't know what their second allele is. So down here, we can't be sure of what these are, or what these two offspring are, but we do know that this offspring is little n because they don't have the disease. All right, let's go to the next page. Here we're talking about albinism, which is a disease where your body does not produce melanin, the protein melanin, and therefore you lack normal coloration in your skin and eyes. And if we read here, we're going to do this on our own. Use the letter A to represent normal melanin protein is produced by autosomal dominant. So albinism is autosomal recessive. So we're going to put little a means that a person has albinism, and a big A is normal. Two normally pigmented parents have 3 children. So let's put a mom here and a dad here, and they're normally pigmented. So all we know is that we have a big A and a big A, and that's expressed normal because it's dominant. They have 3 children, and if we see that this child here is little a, we know that this child had to get a little a from each parent. They have a girl and a boy who have normal skin pigmentation. So we know that they have a big A and a big A. We don't necessarily yet know what that is. The third child, a girl, has albinism. So she has little a, little a. That girl marries a normally pigmented male, and they have 4 children. The first 3, 2 girls and a boy, 2 girls and a boy, have normal pigmentation. So we know big A, big A. Or, I'm sorry, let me erase this. We know that there's at least one big A, and this is one big A, but we know that their parent has only an A, little a to give, so little a, little a. And then over here, their last child, their 4th, a girl, has albinism. So she is little a, little a. Let me just scroll down. And this right here is the last on your homework. I just did it out for the sake of time, so if you want to pause it and compare, and let me know if you have any questions. And good luck. I'll see you in class.